Hi guys, welcome back to the shop. Hey, today I'm going to get on the GT1, GT80 Yamaha crankshaft. We're going to start trying to figure out how we can machine that a little bit. I'm pretty sure I know what I'm doing here, just never done it before. But I'm going to machine that thing to accept the thrust washers so that we can build the crank back up. So I had a gentleman from the Netherlands, and I know I'm going to butcher his name here. I I think it's something like Louis. Uh, anyway, he sent me a picture and a little description on how they deal with the same problem in the Netherlands. I think he said it's a 50cc Kreider engine. And I'm not familiar with that, but he said the same problem is they have with those that don't have thrust washers in it. So he sent me a picture and a little narrative about how to do that, and I sure appreciate it. Thank you very much for the information, and I'm going to show you basically what I came up with from his description and picture, and then we're going to go ahead and proceed to do it. So let me get you overhead here. We'll talk it through it and show you what I got. Okay, this is what we've come up with here. And this, to off-center work on this, we can't pull the stub, so it's got to fit into a groove here. And this is pretty tight fit here. And then I tighten the screw up in the middle and it'll spread this out. It's a adjustable mandrel. And then I put the hose clamps on it over here. I've got two of them that'll fit on it okay. And then I go ahead and center this up to where it's cutting right here. So that's how we're gonna recut this piece. And the picture he sent me was very similar to this, and that's what I came up with, and we'll just see how it works. Like I say, we've got to cut this down in here about 40 thousandths on each one, and 40 thousandths is the thickness of this, 1 millimeter. So let's get to it. Okay, let's see here. I think I've got this. Yeah, it looks like there's one little jumpy place in there. There must be a divot or something. But I'm within 1.5 thou as far as level goes there. Let me get my gauge hooked up for measuring inside. Okay, I'm measuring inside the hole here, and that's really good at less than a half thou. Okay, we're zeroed out on the digital readout, and I've got it down here where I'm just starting to take something, I think. It's pretty hard to see. I need to get another light in there, I think. Hopefully that won't mess you up too bad. Okay, let's see what we got here. Okay, I don't think I'm taking anything there. But I'm going to go all the way across. Yeah, it is, just a little. Okay, taking a little there. All right, let me give her a little more. It's looking pretty good. Okay, it's looking nice and smooth. So we'll just continue on. Okay, I'm just going to continue on here. a little over halfway. We need to take 40 thousandths. Actually, I think I'm going to take 42, and we're right at 24 right now. Seems to be happy taking about 4 thousandths a cut at this speed. If you get going very fast, the off-center condition starts moving things around. This is really the last cut. I'm going to take a couple of tenths just to try to smooth it up. Feels good. Okay, I like that. Just got to chamfer that where we've cut it there, and it should be good. This is cut to just the right size, and then as I tighten this up, it'll go ahead and swell, and that holds it in there, keeps it from moving. Okay, this was the one that had the most wear in it. It was the side that the rod was worn on. This is that side right here. So it's going to take a little more to clean it up. I've been trying oil on it, and it does seem to help. So I'll continue to do it. There's a little more wear there than I estimated. I thought there were 2 or 3 thousandths, and looks like, you know, if it cleaned up this time, It's right at 4. Yeah, it looks like about 4 cleaned that up, so it's just a thousandths more than what I kind of guesstimated. Yeah, it's looking good. I've got about a 1 degree angle on this boring bar so that I can cut with the tip of this, and I've got clearance for the rest of the blade. For those of you that think I'm using it sideways there, it seems to work pretty good. It's just taking her easy, not in a hurry. Cut's pretty good. It's pretty soft. None of that hard stuff that was in that, like in the Suzuki one. I'm surprised that they didn't harden something here, but I'm glad they didn't. Makes cutting it a lot easier. Okay, this is the last cut. This is just kind of to smooth it up. Okay, should be it. Yeah, feels good. This seems a little sketchy, but it works fine. And I think the reason it works fine is because of the trough that we put it in here. Looks good. Just got to clean up that edge. Okay guys, we've got all this taken care of, but we've got one little issue that we need to address right here. We've got to be able to get in here to set our gap. And we don't need to take that whole thing down, but we need to take enough down so we can get in there. And, you know, enough to really be able to get a good measurement. So probably about 50 thousandths or something like that. I'll just start with an end mill, and I'll drop this down right here, and then I'll probably scallop this back on both sides with a grinder, and that should probably do what we need it to do. We just need to get in there. I've already got the other one set up in the mill over there, so I think you can see on this one. See what the issue is there? Just about what we took off. Not quite as much probably. So let's get over there and do the first one. I'll take it just a little further down. Okay, once we get all this out of here, like I said, this piece right here was too high in order to get our feeler gauge in there to check it, to check our clearance. So we had to remove a little metal right there, and that's what I did. With the end mill, and then I just took my grinder and finished grinding this out and kind of dressed it up, and also had to kind of dress these holes up right here that kind of come into there. We don't want to leave any burrs in there, and we've got all that pretty well taken care of, I think. So the next thing that we're going to have to do is see where we're at on what we did here. So we put our shims in, and our bearing, so all this go in there just like most crankshafts do, and then we want to get our clearance between the rod and I got to get this situated where it can just set there. Let's see what our basic dimension is here. 3794. When we took it apart, it was 3794 at the pin and at the 180 degrees. So that's right where we want it to be. And the other issue was to make sure that our pin was not sticking out too far. I've got to kind of push this around, and you can see here that it's well within the inside the hole where it's not out past this raised area, and same on this side. And this pin, if you remember right, I just spun this out of aluminum and I made it to the same length as the one that's going to go in there. It was just so I could experiment with the with how it was going to work, and I think it's going to work just fine. So with these, usually it's the most critical thing is the width. That alone tells you whether it's going to fit back in the case or not. And even though this had the clearance in there, it didn't have the washers. So what we ended up doing was getting all this wear on one side of the one side of the connecting rod, and on one side of the crank halves. So this side here, the mag side, was the one that was wore out, and of course this side on the rod. It removed a lot of metal, and evidently Yamaha figured this out, and they needed that they needed to do something, and they, in the later models, I believe in '77, they went to the thrust washers on it. And I think I'd mentioned that if you look it up, if you look a crankshaft up, a complete assembly for a 1973, which this one is, it uses this, you order the same part number crank as you order for a 77 through 80 or whatever it is. So they are compatible for the older ones too. I think what they did was they did just what I did. So this, I think, is gonna, we've got plenty of clearance in here where the rod goes and between them and all that. So really all we did was remove that metal that was in here on the halves and replace it with the thrust washers. That's all we did. So it tallies up basically to the same width. Well, it was the same width, and it will work on either a 73 or a 77 or 78, wherever they started doing this modification for their new bikes. Okay guys, thank you very much. Don't forget to thumbs up. So really the next thing we need to do is get ready to build the crank. I think we've got all the machining done. I'm going to give this a good cleaning, all the pieces, parts, and then we're going to go and do a build. And that'll probably be in the next video on this bike. And at that point we should be able to get ready to start building that back up. Okay guys, there you have it. I think we've got our crankshaft ready to build up. It looks like the dimensions are going to be as they should be, and shouldn't have any problem. This thing should last real good as long as it's taken care of, gotten the proper amount of oil and all that. I don't know. I've never done this. I don't know whether there's other ways to do this, but really there's only one thing that's got to happen. You got to get rid of some material so you can put the spinning type material back in. If we hadn't modified this, it would have been too wide to fit in the case. So you had to take away the 40 thousandths on both sides to replace that 40 thousandths with the shims, and now we should put the rest of any of that wear issues that we had originally with the crankshaft. So I think it's going to work real good. This is the way most cranks are set up, and there's just no reason why they shouldn't have done this to start with. Probably just trying to, they probably thought these things aren't going to last that long anyway, so why put the extra money in it? You know, that's what, another $6 a side to put that in. Or is it? I think it's actually more than that. Yeah, they are $6.23 a side for those thrust washers. But that'll make all the difference in the world. So next time you see a video on this one, we'll be putting that together. Then we'll be able to go ahead and start putting the cases together. So hey, thanks for going along on the ride, and we'll see you next video.